Hi, everyone. Welcome to Ethical Machines. I'm your host, Reed Blackman. I want to bring you to the cutting edge of a debate about bias in AI. It's one of the biggest issues in AI ethics. If there's the issue in AI ethics, it's bias or discriminatory algorithms or models. And my conversation is with Professor David Danks. He's a professor of data science and philosophy at UCSD, doing some really interesting research. And the conversation that we had really is at the cutting edge of AI ethical research. And it's a crucial conversation because getting this right is essential for creating the right policies, the right regulations, the right activities by people building and testing these AI models. So that's where the conversation is going to get to, a very cutting edge issue. But I want to make sure, of course, that everyone is on board before we get to the very cutting edge. I want to make sure that everybody understands the core. If you do understand the core of bias in AI, where it comes from, feel free to hit, fast forward for a couple of minutes. But for those of you who are not totally on board with where bias comes from or what bias AI is, or even what AI is, let's go through it just a little bit. So look, whenever you hear AI, I want you to think about software that learns by example. The vast majority of AI around today, also called machine learning, is software that learns by example. So you can give it examples of what your dog Pepe looks like, photos, and it'll learn from those examples what your dog looks like in photos, so that when you take a new picture of Pepe, it'll tag it Pepe. That's your dog Pepe. And if it's not your dog Pepe, then it won't label it, as long as it's learned enough from those examples. And if you want a fancy word for example, you can use the word data. So it's software that learns by data. The more examples you give it, the more data you give it, all else equal, the better the AI is, the better sometimes people will call it the model is. Okay, so that's really the core of most AI right now, software that learns by example or software that learns by data. All right. Once you see that, you can see one of the major sources of ethical risks in AI, which is biased or discriminatory models. There's lots of examples we can give here. I'll give you two. So one example is facial recognition software. If you want your AI model to be good at recognizing faces, then you need to give it lots of examples of people's faces. But if you only give it, or you give it mostly pictures of, let's say, white men in all sorts of lighting conditions, and you give it very few pictures of Black women in various lighting conditions, it's going to be really good at recognizing men and really bad at recognizing Black women. And in various cases, that could be a problem. So that's a simple case of biased AI, where it sort of serves, if you like, to the extent that facial recognition software is serving a good goal, it'll serve white people, but not Black women in that particular example. Now, and the solution there is, well, give it more examples of what Black women look like, different Black women, different skin tones, and different lighting conditions. So that's the answer there, or at least that's plausibly the answer there. That's how you mitigate the bias of the model. There's other kinds of examples, which are going to be relevant to the discussion you're about to hear. So there's a very famous example where a few years back, maybe 5 years ago, Amazon was creating AI hiring software. So it gave it a bunch of examples of what good resumes look like, because they get tens of thousands of resumes a day. So if you give the AI examples of what good resumes look like, then when you give it a new resume, it should be able to say, yeah, that's a good resume, the person deserves an interview, or no, not a good resume, don't give them an interview. Now, the examples that Amazon used in this case was their hiring data from the past, call it 10 years. I'm not exactly sure how long it was, but let's call it 10 years. And what it learned, what their AI learned from those examples, what it learned from that data is, we don't hire women around here. Now, there's lots of explanations for why the data looked that way. One thing is that it's not because the data scientists or the data engineers building the AI were hostile towards hiring women. It just showed up in the data. The data reflected some kind of, let's call it, bias against women in the hiring process. What explains that? Well, there's various explanations. It could be that hiring managers who were looking at resumes in the past 10 years manifested explicit and or implicit biases against women, and so tended not to interview women. It could be that due to various kinds of discriminatory attitudes towards women in STEM, women are discouraged from going into STEM, and thus you're going to get fewer women in the STEM pipeline, so they're going to get fewer applications, and so Amazon inherits a problem. It could also be that, let's say, men lie on their resumes more than women do. in which case men are going to get, all else equal, more interviews than women. All these explanations are plausible explanations, and I'm sure that there are more. But at the end of the day, what's important to understand is that those examples that the software learned from, what gets called training data, reflected biases in such a way that the AI learned we don't hire women around here. And so that when you gave it a new resume, it would red light it if it was a woman's resume and green light it if it was a man's resume, all else equal. This is, for some people, this is a sort of a bias horror story. One thing I want to flag for what it's worth is that I'm frankly impressed that, 5+ years ago, Amazon even thought to look to see if their model, if their AI was a biased one. They tried for 2 years to mitigate the biases of this model, or they worked on this model for 2 years, tried to de-bias it, and they couldn't do it. And to their great credit, they actually scrapped the model. They scrapped the project. So that, frankly, even though it highlights, it's a really good example of bias in AI, it actually highlights, in this particular instance, I'm not saying in all instances, but in this particular instance, Amazon doing the right thing. So that's, those two examples, the facial recognition one and the Amazon hiring one, should help you to see examples of biased or discriminatory AI. And there are other kinds of examples. So it's not just resumes, but it could be applications for universities. It could be applications for a mortgage or other kind of loan. It can be applications for insurance. And you can see in all these cases, those examples, that historical data that you're going to train your AI on, may reflect biases or discriminatory policies, or just other kinds of things like men lying more that would result in training data that would result in a biased or discriminatory model. So it's a really big and tough problem, and there's lots to say about it. But the default thing to say, and this is not just true in most AI ethics circles, and it's not just true when we're talking about policy and regulation, including things like the European Union Artificial Intelligence Act. But one of the core things that everyone thinks is, you can't have biased models. Get rid of discriminatory models. You have to make sure that you mitigate the biases of your model. Biased AI is bad, full stop. Get rid of it. And that's a totally intuitive, natural, reasonable thing to think. What's really interesting, though, about the conversation that I have with Professor David Danks is that that's not necessarily true. There are reasons to think that, at least in some cases, having a biased model is a perfectly acceptable thing, given certain conditions, caveats, etc. The general point that you should really look out for is that an AI model is this piece of tech that's embedded in a larger system. And what we really want to make sure is that the system doesn't result in ethically discriminatory impacts. That's what we want to stop. It's possible that you could have a biased model inside of a system where there's other things in the system to offset the biases of the model so you don't get discriminatory impacts. That's the core of one of the things that David and I are talking about. So that's your sort of primer on the basics of AI. It's software that learns by example. That's your primer on bias in AI and why most people think biased models are bad. Let's make sure to get rid of them. This conversation will take you to a more nuanced thought about it, which should help us form really good policy, whether we're talking about governmental regulation or internal corporate policy for how AI gets designed and deployed. It's a really fascinating discussion. So I hope you enjoy it. And more importantly, I hope you get a lot out of it. Today, I want to talk with you about at least one of your research projects that seems really interesting. The general issue is about biased or discriminatory AI and what to do about it. And the part that I really want to get to is the controversial bit, or at least not controversial, the really difficult bit, about when is it justified, ethically speaking, to use a biased model? And when might it even be a good thing to use a biased model? But before we get into that, why don't you give us, a 1-minute crash course in biased AI, discriminatory AI, something along those lines?
Yeah, no problem. So, bias and discrimination in or through AI systems is sort of everywhere in the news now. You can't pick up a proverbial newspaper. Actually, do people pick up newspapers anymore? But you can't pick them up without seeing articles about the ways in which people are being harmed or discriminated against by AI systems. So it's led to a number of companies, governments, organizations declaring that what we need to have algorithms that are not biased. in some sense. Now, the problem is that when we think about what bias is, sort of from a maybe more philosophical or conceptual perspective, bias is really just a deviation from some norm or some standard. So we can think about statistical bias. We do this all the time in data science. We talk about the bias variance trade-off as a thing that governs our learning systems. We can think about moral bias. That's maybe what people usually think about, where you're discriminating against somebody or you judge them poorly purely because of morally irrelevant features. We could think about social biases, where certain people are not treated as well because of the class that they are a member of. Legal biases, the kinds of things that the Equal Employment Opportunity Commission enforces through investigations, right? So there are all of these different kinds of biases, and they really depend on the norm or standard that we're judging against. And one of the things that's become clear in the last 10 years is that there's no such thing as an unbiased system. I mean, in any real sense. Usually what we have to do is we have to pick between, say, a statistical bias or a moral bias. And this can happen most obviously when we have data that come from a biased system. So a very common example would be if we think about hiring practices, which in many sectors are in part have a history of discrimination, whether it's racial, gender-based, or disability-based, other kinds of discrimination. So if all I do is look at the historical data, I'm going to build a model that is statistically unbiased. It actually mirrors the historical statistics that I was given, but it's going to be deeply morally biased. Or I could train a model that is statistically highly biased. It doesn't look anything like the historical statistics, but is morally much more fair. And so a lot of the debate right now is where should we fall in these various choices? And how do we make sure that we're making these choices intelligently, especially when we have people who are trained in data science or computer science who are being asked to make decisions about moral and ethical biases?
So it sounds like one thing that is coming out of this is that I think we should recommend to people that given that the term bias is multiply ambiguous between statistically biased versus statistically unbiased, which may or may not be ethically good or bad, there's no judgment associated with it. Then there's ethical bias. Perhaps then we should just stop using the term bias in isolation and make sure that whenever we refer to bias, we're always saying statistical bias, ethical bias, legal bias, etc. How's that sound?
I would love that. It's what I try to get my students to do in my classes. I'm under no illusion that I'm going to be able to change journalistic practice. So I think at that point,
maybe data scientist practice.
Exactly. So I think changing the practice of data science, changing policy, and having our policies be better informed. I think that that's a really important piece because we're increasingly seeing regulation, the New York City Law 144, a bias in automated hiring decisions. And the language is, I think, really unclear about exactly what it is that we're trying to detect, protect, mitigate, precisely because it just says, oh, don't be biased. That doesn't mean anything in some sense. Right, I mean, as a data scientist, I don't know what to do if you tell me don't be biased.
One thing that you can do when you have a biased model is toss it. That's one obvious option. You say it's too biased in the sense that it's discriminatory or it's ethically biased against, say, women when in the hiring process, so you can toss it. You can engage in various bias mitigation techniques. So maybe you can talk a little bit about that. What are some ways we might de-bias a model, or at least mitigate the biases of a model? And here I'm talking about, I think I'm just talking about ethical biases, but tell me if I'm wrong about that.
Well, so one of the things that's happened in at least the technical side of all of this is people have done a lot of work trying to translate some of the ethical notions into statistical ones, roughly. If this is what we mean ethically by fairness or being unbiased, here's what that would look like in terms of the performance of the model. And the value of doing that is that now we can, as you said, take steps to try to, from a technical perspective, minimize or mitigate the moral or ethical biases that we're worried about creeping into our models. Customarily, we divide the ways that we can do that into sort of three categories. We can do what's called pre-processing, which is where we essentially modify the input data to our training, to our learning system. So for example, we might say, well, wow, there's not as many women in our data set as we thought. So we need to, oversample women, or we need to increase the weight on those data points. Sweeney's work on the Gender Shades project, the face recognition one that you alluded to, That's part of what they
Sure.
did. They constructed a better data set that didn't have the kinds of biased statistics that made it hard for the system to learn for darker skinned feminine features. So we can do that with pre-processing. We can do what's called in-processing mitigation, which is where we, basically say we don't just want to maximize accuracy. We want to maximize some combination of accuracy and balance across groups as a kind of statistical measure that can reduce bias. And so that's where we're literally just learning different models. It's not that we've changed the input or changed the output. We're changing how we learn. And then in
So
post-processing
there's really.
methods,
Oh, sorry. Yeah.
what we do is we take a model that might be horribly biased, and then we use different thresholds for different groups, or we teach people how to use the model differently. So that's sort of after the fact approaches.
So option one, toss your biased model. It's ethically biased in a way that's unacceptable. Option two, try to sufficiently de-bias it, ethically bias it. Rather cumbersome phrase. This is why adoption is difficult. Try to sufficiently ethically bias the thing. If yes, proceed to go. If no, option number one, toss it. What are though, and we've talked a little bit about this, it seems like there are some examples in which it's okay to use a biased model. You've got a biased model on your hands, but don't toss it. It really is in some well, I'll just leave it open, I guess. I'm going to say it's biased in some sense, but it's still appropriate to use.
Yeah, so one of the things that can make it so a biased model could be okay to use is we now have some examples where people have basically done education of the end user in a way that the end user can start to compensate for the biases. Now, I want to say right off the bat, this is actually really hard to do. We know that people typically don't compensate enough for the bias. But, if you tell a human, look, this thing probably is overlooking some women in the applicant pool. And if you design your system not to say, here's the best applicant, but simply to say, here are the 25 best. And yes, men are going to be overrepresented, but there will be women in this group. So please make sure to take an extra careful look at that, right? That would be a kind of hiring example. People have shown that you can actually significantly improve matters to the algorithm itself. There's a very nice set of work that was done by people at Carnegie Mellon looking at human and algorithm integration of information about child welfare calls. Basically, people call that, something's happening at their neighbor's house, which calls get investigated. And the model that they built was actually kind of biased. I mean, it was, in fact, more biased than the humans had been. But the human plus machine together was less biased than either individually. Okay. And so that's an example where you can actually just teach people, here's how to do it better, recognizing that's never going to be perfect. So that's one of the standard things that people would do is if you realize that it's biased, you just, have the people compensate for that in some way.
So that's interesting because I thought you were going to say, look, there are cases in which you have a biased model, but it's less biased than the people than your average hiring manager. So it's okay to use. That's one case. But what's interesting about your example is that it's a case where the model is biased. In fact, it's more biased than, say, the average hiring manager. But there's this interesting empirical finding that the more than human biased model plus trained human is less biased than either of those two in isolation.
Yeah, I mean, that's the good story, right? That's the good example of this.
Yeah.
And we see this actually in a lot of contexts. I mean, human plus computer chess players beat computer chess players. I mean, in general, computers win at chess every time over humans, but a human plus a machine beats the machine, right? So there is still some value added that humans provide, and it is in part the contextual factors that can help with things like bias. Okay. Now, sometimes I will say we also just want a biased model because, we humans have our cognitive biases, right? We overestimate the importance of rare events. And so, you might want a model that, makes up for our difficulties cognitively. We see this in some of the things that happen, for example, in present day airplane cockpits, where there's a lot of algorithmic transformation of the information that's shown to modern pilots. They're not actually looking at dials the way that they used to. And some of those transformations are deliberately done in ways that compensate for our human cognitive foibles. So it's, they average the heading because small variations in the heading would lead the human to intervene when in fact it's just fine. It's just the normal. People are bad at
Mhm.
detecting, differentiating noise from signal. And so I think we're very used to this idea that a lot of times we want, we're bounded, limited critters. And so if an algorithm can help make up for some of our cognitive deficits, we think that's a good thing to do. I mean, that's the whole field of human factors is devoted to figuring out how to do that.
Yeah, this is sort of why people sometimes want to refer to artificial intelligence as augmented intelligence.
Exactly. That we should not think about AI, and this I think is true more generally. I mean, there's a whole set of discussions about economic justice here, but that we need to think much more generally about AI as complementary to humans rather than as competing. I mean, in general, if a human is good
Yeah,
at
be both,
something,
right?
machines are not great at it, and vice versa, right? Machines are great at
Yeah.
doing the same thing over and over. We're terrible at it. We're great at creativity and understanding and language. Machines are struggle with things like understanding.
So, okay, so right now what we're talking about is what do you do with biased models? And there's the pre-processing, in-processing, post-processing. Do you consider the training of the people as part of post-processing? I mean, it is post, but is it too
Yeah,
far
I,
post
I
so that you put it
would.
into the
I would
category?
because no, I would because much of the time that training really has to be done in close collaboration with the data scientists, with the AI researchers. I mean, it,
Right.
the people who built the model are the ones who understand what needs to be compensated for. And so it
Yep.
really is
Yep.
part of the broader training and development effort.
Yep. So let's zoom out though a little bit because right now we have a kind of somewhat of a clear line from model development by data scientists to the user. They have a conversation, that person uses it, you've got an impact, and you're hoping that that impact is ethically acceptable. But if we zoom out a little, we see that the model exists inside of a broader system. And there might be other places in that system where the biases of the model don't lead to ethically unacceptable impacts. Can you talk about that for a little bit? Does that make sense?
Yeah, I mean, I think that that's something that people are increasingly coming to recognize. So maybe it's easiest to explain through relatively recent example. So a lot of people may have heard about the use of algorithms to improve bail sentencing, right? So when somebody is brought up and arraigned for a crime, oftentimes they are, provided some bail, like pay this amount of money, and if you don't come back to be tried, you lose the money, right? It's basically a way to get people to come back for their trial. And there's just an enormous amount of data showing that bail judgments, bail recommendations are ethically biased against defendants of color, against lower socioeconomic status, lower educational status defendants. And so a lot of data scientists have said, well, this is actually a beautiful, in a certain sense, data science problem. We've got the number of what was provided as the bail, and then we know, if we look back more than a year or so, we know whether the person came back for their
Mhm.
trial. So we can actually estimate the probabilities, given various characteristics of what they are charged with in the individual and all these sorts of things. We should be able to do better. And in fact, people have made models for bail recommendations that are, you know, completely by any measure you'd want to come up with, in my judgment, basically completely unbiased from an ethical perspective. They are incredibly good models at that part. And they also turn out to be more accurate. Like they better predict who's going to come back and not.
Mhm.
So one of the challenges is that in the United States, judges cannot be required to follow the recommendations of these algorithms. They have to be allowed to use their own judgment.
Sure.
And rather infamously, in Kentucky, they rolled out one of these algorithms that was much fairer about bail recommendations. And when people looked back at the statistics after it had been rolled out, they saw that there was essentially no change in the ethical bias of the bail recommendation. The judges simply ignored it for defendants of color, ignored it for lower socioeconomic status, and they listened to it for others. Right.
Okay.
So it wasn't that the judges completely ignored it in all cases, but they differentially ignored it for exactly the people who had historically been biased against.
Okay.
And so that's a case
So
where
the
we
idea
had
is
this.
something like, yeah, this computer said, so the explanation is something like these judges harbor some kind of discriminatory attitudes, conscious or not, towards people of lower socioeconomic status, people of color, etc. And so for that reason, they're more inclined to think that the computer's got it wrong.
Exactly. And maybe they don't consciously think it, right? They just like
Sure.
go, that number just seems a little odd. I'm going to bump it up just a little bit. And they
Yeah,
can't
sure.
articulate why, and they don't have to, but we're left in a world where we have an algorithm that could do it much better by any ethical standard you want,
Mhm.
but the rest of the system conspires against them.
Sure. So let me ask you, I think I see where you're going, but before you get there, why not then just get rid of the judges? Why give them that wiggle room if we know we've got a system that's ethically superior and bail, what is it, risk ratings or something along those lines,
Essentially, yeah,
predictions?
bail recommendations.
Why not just use them? Is-
So there's a couple of reasons.
and the model can be subject to certain kinds of auditing requirements, yada yada
Right.
yada.
So the practical reason is because state legislatures don't want to do that. Every time somebody's tried to do something like that, it gets challenged. And shockingly, the state courts decide that the judges should not be forced to follow the algorithms. There are some rather famous cases where essentially that's what's happened. But I think that the deeper question, or at least the challenge to that proposal, is whether we think that there are some decisions that actually ought to be made by people. And I think that this is a really hard ethical question, are there some decisions that we think are of such importance where contextual factors really might matter that we think there's something like we need our shared humanity? I mean, this sort of argument comes up a lot when we think about, to go to a completely different example, when we think about things like autonomous weapons systems, where there's a lot of people who say, look, the decision to take a life should never be made by a machine. That's something that, that's part of our shared humanity. So I do think there's actually, I don't know that I agree with that. I mean, this is one of these, I don't know what my own view is, in the case of, say, bail recommendations. But we hear this.
I take it though that that kind of thought is really the thought that sometimes it's going to get it too wrong. It's a concern about inaccuracy in high risk circumstances. So if you had an AI that were sufficiently sensitive to context, which includes sufficiently sensitive to morally relevant features of the situation, like, oh, this person was abused as a child, or, this person suffers from a certain kind of disease, which would, in the human's eyes, mitigate the extent of our blame or the extent to which we hold that person responsible, or let us, gives us grounds on which to be justifiably more merciful in a way that an AI might not, then that could make a lot of sense. But there, the concern is something like it still sounds like maybe it's not. It sounds to me like an accuracy issue. If you include among what counts as accurate, the right, all things considered judgment to be made about this person, the recommendation to be made.
I think some of it is about accuracy, but I also think that, and again, I want to preface this with, I don't know if I agree with the argument I'm about to make, but it is definitely
Sure.
one that I see from a number of people, and I see the appeal of it, which is the argument that says, look, there's certain things that we owe to one another, that there's certain decisions that, part of being human is that we take this upon ourselves. We don't outsource this, or we don't outsource this even to other people, right? That there's certain decisions that are too important to be made in this sort of way by a proxy, that these shouldn't be done by proxy. I mean, and I think, again, I don't know if I agree, but I
Sure.
feel the appeal that there are certain things we owe to one another that we ought not outsource, especially to a machine, because that seems to absolve us of responsibility, right? I mean, that risks us being in the position where sort of nobody's taking responsibility. Nobody is owning the decision. Nobody is grappling with the moral complexities of the decision. I mean, unless we think the
Yeah.
machine is able to do that. But, I have my doubts about whether current algorithms are really, wrestling with moral complexities and ambiguities.
No, they certainly are not. Yeah. I mean, okay. You're going to have to come back. We're going to have a whole discussion about that, because I also find that fascinating. I mean, of course, I feel the intuitive pull of that's not the kind of thing that we should outsource to a non-human anything. There's something about our humanity that's at stake here. If we don't engage in those kinds of deliberations and inquiries, we owe it as a matter of respecting other people's dignity, that part and parcel of taking them seriously as people is that we take the time and energy to think deeply about the situation that they're in and ensure to the best of our ability that they're treated justly. And it seems like what's ethically important there is not only the result, at least I take it this is what the argument is. It's not just the result, whether the outcome or the consequences of the decision are the right one, but that part of being ethical is engaging in that kind of process itself. The process of deliberation is itself part of the process of justice.
That is the idea. And then I turn around and say, And are we going to allow people to die because we want to feel better about how we made a decision? Right. I mean,
Right.
that's
Right.
the sort of pragmatist and utilitarian in me says,
Yeah.
but literally people are dying who didn't need to
Yeah,
because of
right. So I'm
this.
glad you engaged in that really, subtle and interesting ethical deliberation, but you got it wrong and the computer would have gotten it right.
Yeah.
And so now this person's dead or in jail for life or whatever. So, you know, you're engaged into kind of like, I don't know, human fetishism or something like that. That's not ethically helpful. Okay.
And well,
So
and I
that's that,
think,
yeah.
well, let me just say, I mean, I think that this focus on, the outcome versus the process, I think is really important when we think about, how
Yeah.
we can respond to these other parts of the system. Because if what we really care about is the outcome, then we should be willing to entertain things like, maybe the Kentucky bail people should have biased their algorithm in the opposite direction, expecting that the judges would bring it back. So you end up at the right place by having sort of two wrongs making a right, as it were.
Yeah, good. So this brings us back to what can you do with a bias model? When is a bias model good? And I take it this sort of, if you like, new proposal, and I know this is an area of research of yours and your teams, from what I gather, is if we know that a system is ethically biased in a really in an unacceptable way, so it systematically discriminates against people of color, women, people of a certain religion, etc. So if we know that fact, and we know that we're going to introduce some kind of automated decision-making process, AI, ML, whatever. We're going to introduce that into the process. We also know that, given the facts on the ground, that it doesn't just go from algorithmic output to consequence because there's, for instance, a judge, there's a human in the loop who's going to do something with that output. Wouldn't it be ethically permissible to make it ethically biased in the opposite direction, such that the ultimate output of the system is just or less discriminatory than it would have been otherwise? So we get this hiring software and we make it the case that the hiring software gives extra points for being, say, a woman or Muslim or black or whatever. And used in isolation, arguably, it would be ethically unacceptable. Unless you've got some ideas about something like we owe it to these people as a matter of justice, as a matter of reparations, to give them more weight, blah, blah, blah. Put that to the side. Let's just assume for the sake of argument that it's not okay. Nonetheless, it would be okay if it's combined with a discriminatory end user so that we get a balanced output. Do I have that right?
That is. And, the thing that I think is, on the one hand, really appealing about this idea is that, especially I as a data scientist, I can't change some of these structural factors. I mean, if I'm building a system to help a healthcare network do resource allocation, and I discover that, communities of color are systematically not receiving enough resources, I'm not going to be able to change the structural features of an entire healthcare network as one
Sure.
individual or even as a small team. But if I can, nudge them a little bit in the right direction, right? That feels like a way for me as a data scientist to, try to increase justice in the world, to be able to make things a little bit better, to not be contributing to, efficiently discriminating against people in communities. On the other hand, I'm clearly substituting my judgment for, I'm not going out and talking to the communities. I'm doing something in a certain sense surreptitiously. I'm not going to, if I tell the healthcare network, oh, by the way, I did this, then it's likely to have been an ineffective response. And so it also seems that I'm professionally, at least, doing something really problematic. I'm not doing what I should be doing. I am being deceitful and, deceiving people in the interest of the greater good. There's a very long history of that going badly. And so I think that there's a strong, I sort of feel personally and professionally when I'm doing my research, and this is why my team is, as you said, working on this question, is sort of what are the conditions under which this would be morally permissible, maybe morally obligatory? And in particular, what are the conditions for me as an AI research, as an AI developer, AI engineer, a data scientist, right? Obviously, the best thing would be for the healthcare network to just stop being structurally racist. But that's not sort of on my menu of options. I don't get to pick that as a data scientist, as a thing that I'd like to see happen. So what do I do?
Yeah, it's such a difficult question. First of all, even if we stipulate that the data scientist knows all the, if you like, the non-normative, the non-ethical facts. They know about how the system works. They know how the stakeholders feel about things. Even if you stipulate that, there's still a question as to whether the person is, if you like, authorized to tinker with society in that way. I mean,
Right.
you're a team of data scientists at a private company who knows how the healthcare system works, and there may well be systematic biases, but there's a question about who ought to actually be the ones responsible for doing it, and can someone act in a way that would otherwise be ethically good, but they're sort of overstepping their bounds. That's one issue. The other issue is that there's so many variables in the system, right? There's just so many variables. I mean, aside from what's going on standardly, like there's this state law and that regulation. This is how this hospital works, and these are these incentive structures in this hospital, but the incentive structures in this other hospital are different because blah. There's just dozens, hundreds, thousands of variables. So there's this other worry that, again, if we were talking to philosophers, we'd call it an epistemic worry, but we can just call it something like it's a problem having to do with lack of knowledge of all the variables. How is the data scientist supposed to know how their intentionally biased model is actually going to impact the system overall?
That's part of the really hard question.
Yeah.
The first thing I would say, and this is maybe an unfair oracle move for me to make, but I'll make it anyway, is to say, I can agree with everything you say, and also say that that's how we end up with absolutely horrible AI systems that perpetuate and exacerbate inequalities and discrimination. Is everybody says, well, this is really complicated. It's someone else's job. And I know you didn't intend it that way, but I think that the kind of response that you gave, it treads dangerously close to the everybody thinks it's someone else's job, and so nothing is done about the structural. I mean, that's part of what we mean when we talk about things like structural racism, is it's not because of this one person or this one group. It's the whole way the system is constructed. And so inevitably, it's going to be very hard to predict what would happen if we did an intervention of one sort. So one of the things that I think is important to acknowledge that, not only is the data scientist in a state of epistemic uncertainty, but so are the hospital executives and administrators. So are the patients, right? Nobody quite knows how these systems are going to evolve. So, and I don't think that that's true that's an issue just in the case of, say, these kinds of issues of compensating with our algorithms. I think that's a general point that we as AI engineers need to be a lot more focused on how we deploy and monitor rather than deploy and forget, right? Because our systems are always our AI
Sure.
is always going to change our systems in unpredictable ways. And so we need to be doing this. So
Yeah, sorry.
well, so let me just quickly say, so one way to think about what we might do in the case of these kinds of potential compensations through our algorithms is you can imagine that what you do is you basically deploy it in a biased way, something that's deliberately biased in the other direction, but you build in monitoring and revision things, think reinforcement learning kinds of stuff, that will naturally bring it back to a more stable point, basically, if this intervention doesn't make a difference.
Yeah.
Right.
Let me try to rephrase that. So I take it that one of the responses to the concerns that I raised are, one, look, you got to do something. Once you know, you're a data scientist, say, once you know about the kinds of inequalities or biases in the system, or the ethically bad outcomes more generally, once you know about them, and you are in some in sense intervening in that system. I just mean causally intervening. You're gonna do something that has an impact on the system. Once you know that, you have some kind of responsibility to counteract that ethically bad stuff. And then there's a second part of that, which is the how you intervene. And there, I take it, what you're highlighting is some level of due diligence has to be reached. So that means before you make the model biased in some way, you're first going to have to do some kind of amount of digging to figure out what are the sources of the existing discriminatory impacts, how might our potential solution interact with those existing sources, and how might they counteract them. And part of that due diligence is going to be that it's a continuous due diligence process, meaning we'll continue to monitor the AI and its impact within the system until the model is retired.
Yeah.
And I guess the sort of other thing to sort of really push is to say something like, and what else would you want? The alternative is that the data scientists knows that they're going to be interacting in the system. They could choose to act in a way that is, if you like, complicit with the existing injustices, or they can choose to act in a way that's not complicit. Don't we want them to act in the latter way?
Yeah, I think that that's a nice way to put the argument. And I think when we put it that way, one of the things that it emphasizes is that in some sense, the obligation of the data scientist is to try to do something to address the injustices. It's actually not necessarily to, bias their algorithm in the other way. That's the easy solution in some sense. But maybe it is a case where have a conversation with the executives and say, look, this is what our data found. We're seeing this right now in some police departments that have used data not to try and predict where crime will occur, but to analyze their own performance. And so what they're doing is trying to use the data to figure out where are we biased so we can do better. So, maybe this is a healthcare network that would be receptive to evidence that they have been historically biased. That's not something that the numbers aren't going to tell you that, right? There's nothing in what your training is as a data scientist. That's almost more of a business level decision in terms of, would the management be receptive to this? Are there things that you could put into the interface, right? So we know that we can nudge people through the presentation of data and the presentation of numbers. Could we, use this to nudge people towards the more just while still giving them historically accurate predictions? There are a lot of levers that you could pull. Part of what we're exploring though but one of those levers is changing the algorithm. And is that ever a lever that we ought to pull?
Okay, so we've run through a lot of things here. Throughout the bias model, try to engage in bias mitigation strategies and tactics. If those work out well, keep going. If not, maybe throw it away, go back to option one. There's educating. This is a subset of the second one, but educating the end user. So use the biased model, but educate the end user in a way such that the overall impact is okay. There are even potentially cases in which you can intentionally bias the model in the opposite direction, such that it counteracts biases in the system and you wind up with just outputs. 3 connected points or something along those lines. One is that this is all going to require the right kind of it's going to require the right kind of organizational support, right? So you mentioned talking to the executives, talking to those higher level managers. So one is that it's going to be really hard for, if you like, the lone data scientist in a multinational corporation to do this on their own. It's going to require organizational support to engage in the appropriate due diligence that you referenced, right? The second thing is, I'm not sure. One other concern that I have is just that data scientists are generally not well equipped to make these judgments, either due to a lack of knowledge or a lack of skill in navigating the complex issues. So it seems to me like all those things sound okay on the condition that we have different kinds of expertise weighing in on the issue. It's not just the data scientists. So ethicists, civil rights attorneys, sociologists, et cetera, et cetera. And then the third and last thing that I want to raise, and I'll give you the last word on this, is to what extent do you think policy or regulation, let's say, regulations and laws should speak to these kinds of things? I mean, knowing that there's all these different things that we can do with models and biases and how they interact with systems, and maybe then it needs a kind of cross-functional expertise to really tackle them. Do you think that shows us anything about what good regulation ought to look like?
Yeah. So on the first 2 points, maybe this will be unsurprising since I am at a university, but my response is education, 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 right? We need to educate the executives about what's actually going on in terms of data science and AI. We need to educate the data scientists and the AI engineers in how to collaborate with ethicists and sociologists. We don't have to teach them to be ethicists or sociologists. We need to teach them how to work with them. We need to educate the client that when they go to a consulting firm and say, we want a predictive model for X, they should be asking about, what were the value choices in building these models? So for those first 2, I just don't think there's any substitute for education, for getting people to think about these things better. It's something that I'm very passionate about with my own students, with the work I do with companies. It is filled with 90% of the time, it's not doing things, it's teaching people how to think about things in better ways. On the last point, I think one of the things that this highlights is, as you said, good governance is going to only result from multidisciplinary interaction, collaboration, multi-stakeholder efforts. I think the other thing it does, though, and this comes back now to where we, in some sense, started, which was the New York City law. I think it says that good governance should not focus on the algorithm. Lots of the governance that we're seeing right now is very sort of, here's what the algorithm should be.
Yeah.
And the thing is, the algorithm is, in some sense, it's kind of just math. It's how is it embedded within a larger socio-technical system? And what are the outcomes that result from this? If you take something that you can, pick your favorite horribly biased algorithm, just change the use of it, right? Instead of predicting bail, you predict who needs social services. And people would go, oh, that's AI for good, right? I mean, it's the same ones and zeros, right? So I
Yeah.
think that this talk of the algorithm is actually somewhat misguided. Now, in fairness, the New York City law is a bit clearer that they mean sort of the broader TIS system, not just the ones and zeros. But we're seeing this in DC. A lot of the efforts to regulate or to talk about governance are very focused on the algorithm.
Right.
And I think we have to have a broader lens when we're doing to really get to good governance.
That's great. I mean, we'll have to talk about this more at another time. I mean, there's one question about whether they should not talk about the algorithm. They should just be talking about the socio-technical systems and the impacts it has, or if they should talk about both. I absolutely agree with you, though, that just talking about the model in isolation is sort of silly. I also think that talking about biased training data is silly on that point. I mean, there's being biased is not an intrinsic feature of a data set. It's going to depend upon what you're using it for.
Exactly. Yeah, no, and we're too quick to try and reduce things to very simplistic technical things so that we can outsource it to the machine. And we need to really wrestle with these ourselves.
All right. Well, thank you for wrestling with these topics. You like that segue? Thanks for wrestling with these topics with me. Obviously, you're required to come back. We'll talk more. And thanks so much for coming on.
Thanks, Reed. This is a real pleasure.
Talk to you later.